Aquaculturists depend on reliable, high-performing, and energy-efficient aeration systems for the survival and the success of their farm operations. There are 4 major aeration types available to aquaculturists that are being tested here. Aeration Industries' 100,000-gallon research and development test pool offers a unique opportunity to see these 4 types of aerators in action above and below the water surface through underwater glass windows. Below the water's surface, tack marks are visible and extend to a depth of 8 feet. Across the bottom, a plastic jug has been placed at a distance of 10 feet away from the aerator. Destratification is of utmost importance to all aquaculture species. It creates a healthier environment that leads to increased size, increased survival rates, and thus increased profits to aquaculturists. The first aerator being tested is an Aero 2 Series 2 aerator manufactured by Aeration Industries International Incorporated of Chaska, Minnesota in the United States of America. The Aero 2 aerator has multiple adjustable angles for shallow to deep ponds. Here, the aerator is placed into the water at a 45-degree angle. Please notice the depth as well as the distance and area of distribution that's provided by the Aero 2 aerator. Its area of influence reaches a depth of 8 feet and a width of over 10 feet wide. The velocity rate of the plume can be measured by the constant rocking of the water jug, which is positioned at a distance 10 feet away from the aerator. The Aero 2 aerator meets the United States Environmental Protection Agency's definition of a fine bubble aerator. The importance of bubble size and hang time are critical to efficient oxygen transfer rates and oxygen dispersion. The longer a bubble stays in water, the greater the opportunity that bubble has to become dissolved oxygen, or DO. Destratification is accomplished when a pond is thoroughly aerated and completely mixed from top to bottom. Aerating the bottom of ponds is important to species like shrimp because they are bottom-dwelling. Thorough mixing of the pond aids in the control of animal and feed waste, which keeps ponds cleaner and decreases the risk of disease and mortality. Multiple Aero 2 aerators positioned strategically create the important flow linkage, which provides even greater oxygen-rich water and mixing to the entire pond. Here is an underwater view of the Aero 2 aerator in action. Notice how smooth and steady the water flows from the hollow shaft and is dispersed by the propeller into the water. This perfect vacuum is the result of over $1 million United States dollars of research into the Aero 2 propeller product line. The result is a smooth operation with no vibration or cavitation, ensuring a long lifespan and minimal maintenance. This second aerator shown is an Asian-made copy of the Aero 2 aerator. This type of aerator uses a marine-type propeller that is designed to propel or push water instead of creating an optimum vacuum of oxygen-rich fine bubbles. Immediately, you'll notice that the entire sphere of influence of its area is not even half the area of influence of the Aero 2 aerator. Underwater, these differences are accentuated even more. Although these units may look alike, there is a remarkable difference in performance and workmanship. This unit struggles to achieve aeration at only a depth of 4 feet. Also, the distance of which it disperses aeration is hardly that of the Aero 2 aerator. Look at the water jug. It lies stagnant and motionless. And notice the amount of turbulence and air leakage as the propeller spins. This results in poor oxygen dispersion and cavitation. This cavitation causes extreme vibration and stress, as well as wear and tear on parts and on the motor of this unit, which leads to mechanical failures and a shorter lifespan. After viewing this Asian-made aerator's performance underwater, it's clear that this copy does not match up to the original Aero 2 aerator's superior performance. The third unit is the common paddle wheel aerator used throughout the aquaculture industry. You will immediately notice heavy splashing and movement that causes changes in temperature and salinity due to high evaporation rates. These two elements are critical in maintaining proper pond parameters. Subtle changes in these parameters can lead to poor growth rates, to shock, and reduced yields. Unlike the Aero 2 aerator that has only one moving part, this unit has multiple moving parts and is gearbox driven. Such characteristics require high maintenance and also lead to high failure rates. Below the surface, the performance of the paddle wheel is dramatically different than the Aero 2 aerator. Only the top 1 foot of the pond is being aerated and mixed. At the bottom of the pond where shrimp live, there is no destratification of temperature or oxygen occurring. Again, the bottle remains stagnant and motionless, showing this aerator's inability to mix water efficiently. These paddle wheels can be lowered to gain more of an area of influence. However, trouble arises when this is done because these units are unable to withstand the extra load of pushing more water, which leads to premature motor failure. The next aerator shown is a submersible aerator where the complete operation of the aerator, including the motor, is below the water's surface. Aerators which feature submersible motors are suspect to fatal leakage problems that can occur once the seals of the motor cool and expand, allowing water to enter. The unit seen here is only a 1.5 horsepower aerator, the largest size submersible aerator that this company produces. The unit was lowered to a depth of about 3 feet deep. You can clearly see that the bubbles emitted from this aerator are very large and escape quickly to the surface of the water. They are not fine bubbles like the Aero 2. The lack of bubble hang time displayed by this submersible aerator leads to insufficient oxygen transfer and dispersion that is vital to the aquatic species. Even though the angle of adjustment of this aerator can be moved 180 degrees, as long as the bubbles remain large and rise to the surface quickly, this flexible option does not increase this aerator's ability to disperse oxygen underwater. Please note that mixing from this aerator is quite limited and therefore very poor. Again, notice that the bottle, which is located only 10 feet away from this aerator, remains static and motionless of any current created by the submersible aerator. Dispersion from this aerator is only 3 to 4 feet. In many cases, this aerator requires an extra mixer in order to achieve the desired mixing needed in many aquaculture applications. This, of course, leads to increased capital costs and higher horsepower consumption. A closer look at this aerator's propeller again shows that there is a great deal of cavitation near the propeller area. This cavitation can be deadly to an aerator's performance. The Aero 2 Series 2 aerator, as you recall, is smooth in operation and performs with no such cavitation. This aerator can also be lowered to increase its area of influence. However, the deeper the aerator is lowered below the surface of the water, the less efficient this aerator becomes. This loss of efficiency is due to power wasted from drawing air from above the water's surface down to the motor. Think of this as a person snorkeling at deeper than normal depths. Picture the diver's lungs as the aerator's motor. As the diver descends, more lung power is required to overcome increasing water pressure in order to maintain normal breathing. This energy loss can amount to as much as 25% of the aerator's motor efficiency. After viewing this submersible aerator, it is clear that its performance and operation is inferior to that of the Aero 2 Series 2 aerator. The last aerator is an American copy of the Aero 2 aerator, which uses the solid shaft design as opposed to the Aero 2 aerator's hollow shaft design. This design restricts airflow and causes cavitation of the propeller. This results in less efficient oxygen transfer performances and a shorter equipment lifespan. This unit is also constructed of all stainless steel, which results in a much heavier and expensive aerator. The Aero 2 aerator is constructed of lightweight composite material that was developed by the DuPont Corporation to withstand the extremes of either a cold Minnesota winter or a hot equatorial summer. Underwater, you can see again that this unit struggles to get a 4-foot depth while producing bubbles that are large and not EPA-defined fine bubbles. Once again, the plastic jug is stagnant and motionless, visually demonstrating the poor mixing and circulation that this unit provides. After viewing this aerator's performance, it is again apparent that it cannot match the performance efficiencies of the original Aero 2 aspirator aerator, founded and developed by Aeration Industries International. The next time you are choosing aeration equipment, remember the benefits of aeration, mixing, and oxygen dispersion. With the aquaculture industry's trend moving toward zero water exchange, the need for reliable and highly efficient aeration equipment will become more critical. Trust your liquid assets to the best, the most advanced aeration technology serving the aquaculture industry today, the Aero 2 aeration system.